Space exploration has had some interesting technology over the years. NASA has launched large telescopes that have played a great role in discovering other galaxies and worlds out there. For years, the most well-known telescope has been the Hubble Telescope, which has made some of the greatest discoveries in the space industry. But now, there's another telescope in orbit, and it's said to be bigger and better. This is the James Webb Telescope. Even though we're expecting its first images soon, it's already stunned everyone with its test images. So how do the two telescopes compare? Hello everyone, and welcome back to our channel. Today, we'll look at the differences between the James Webb Telescope and the Hubble Telescope as we try to figure out which one has the better images. But before we continue, make sure you leave a like and subscribe to our channel for more amazing updates on what's going on in space. And with that, let's find out which one is better. Ever since it was launched in 1990, the Hubble Space Telescope has helped us discover so much more about the universe than we ever thought. From the vantage point above Earth's light-distorting atmosphere, Hubble has managed to give us some of the clearest and most detailed views of other galaxies, planets, stars, comets, outer planets, nebulae, and even other moons. It has even gone further back in time than any of its predecessors ever did. Thanks to the Hubble Telescope, scientists have discovered the existence of black holes in galaxy cores, measured the composition of exoplanet atmospheres, found the most distant galaxies to date, and even verified the accelerating expansion of the universe. The Hubble Telescope has changed how we view space in all its aspects, prompting further research and revisions to textbooks. Today, you will find pictures of the Hubble Telescope discoveries on mugs, t-shirts, socks, neckties, and even moving vans. But with the Hubble Telescope, there's now a desire to learn more, and that is where the James Webb Telescope comes in. The James Webb Space Telescope is the largest and most technically advanced telescope to ever be built. With its large size, it comes with the richer infrared views that give it the capability to go further back than the Hubble Telescope did, peering back more than 13.5 billion years ago. It will serve to witness the first stars and galaxies that formed out of the darkness of the early universe. Webb's observations will mostly compare the faintest and elliptical galaxies that we all see today, as it guides our understanding of how galaxies came to be over billions of years. It'll be based on the work of the Hubble Telescope. The Webb Telescope has a deeper infrared vision, ranging from 0.6 microns to about 28.5 microns, and it will use this vision to peer through the dust and gas of massive clouds to where stars and planetary systems form. It will definitely look back farther than Hubble's infrared view could, viewing distant exoplanet atmospheres and maybe even finding the building blocks of life somewhere. Hubble can observe in near-infrared light, but it was optimized for shorter ultraviolet and visible wavelengths of light, about 0.1 microns to 2.5 microns. This great difference makes the Hubble and Webb a formidable pair of observatories that, together, will cover a broad wavelength range. Regarding the design of the two telescopes, the Hubble and Webb are both reflecting telescopes. They make use of curved mirrors instead of lenses to collect and bend light to their various instruments, which then go on to record the findings. Most reflecting telescopes have two main curved optics. There's a large concave primary mirror, which is shaped like a bowl, and a smaller convex secondary mirror, which is slightly arched and is directly located just above the primary mirror. Such case-grained designs will offer a long focal length in a relatively compact package. The longer the focal length, which is relative to the diameter of the primary mirror, the higher the magnification and depth of field. However, the Webb telescope has a 3-mirror anastigmatic design, which makes use of a third curved mirror. This helps it achieve better optical performance over a wider field when you compare it to Hubble's Ritchey-Chrétien Cassegrain design. It's easy to notice the difference between the two at first glance. Since the Hubble operates from an orbit that is just above Earth's atmosphere, it needs to be fitted with a mechanism that will block the stray light from the sun as well as the reflected sunlight from Earth and the moon from entering the area where the mirror is. So to achieve this, the telescope was wrapped with an insulated, aluminized Teflon light shield, which gives the telescope a tube-like shape. But when it comes to the Webb telescope, its multi-layered sun shield looks nothing like Hubble's tubular light shield, but it serves the same purpose. The James Webb Telescope has a 21.3-foot primary mirror, which is larger than Hubble's 7.9-foot primary mirror. This gives Webb the ability to collect 6 times as much light as Hubble can. Given the longer and dimmer wavelengths that Webb will be receiving, the wide area is important. Since the universe is still expanding, most light from distant objects is stretched as it travels towards Earth's direction. This means that the shorter, bluer wavelengths of light are stretched to longer, redder wavelengths. Therefore, the distant objects that are in bright ultraviolet or blue light will appear redder and dimmer when the light gets to Earth. Thanks to Webb's larger mirror, it will be able to gather more of this dim light, capturing views of objects that are up to 100 times fainter than the Hubble could. But despite the large size, Webb will still deliver images that are somehow similar in resolution in near-infrared light to what the Hubble attained in visible light. A telescope's resolution depends on its mirror size, and it's inversely proportional to the wavelength of the light observed. Therefore, the larger mirror is necessary to resolve the same level of detail at longer wavelengths of infrared light as Hubble can achieve at visible lengths. With somehow similar resolutions, the two telescopes could team up to make some of the most amazing discoveries ever. For the Webb telescope to capture the longer, fainter, infrared wavelengths of light, it needs to be much colder than the Hubble telescope. Unlike the visible rainbow colors, infrared light cannot be seen with our eyes, but we feel it. Infrared light is heat, such as the warmth you feel when basking in the sun. To capture the heat that has remained from distant objects, such as the ones that the Webb telescope is bound to explore, it needs to be extremely cold. We're talking about temperatures of up to 364 degrees Fahrenheit or negative 220 degrees Celsius. Since it has to be this cold, the telescope has to shield itself from the infrared radiation that is coming from the sun, Earth, and Moon. In addition to that, the telescope has to be further away from Earth than the Hubble telescope is. Hubble orbits the Earth at about 340 miles above Earth. However, Webb orbits the Earth at approximately 1 million miles away, somewhere near the second Lagrange or L2 point. According to Webb's reasoning, the Sun, Earth, and Moon will always be in the same position. This allows its large sun shield to block its light and keep the telescope cool. The Webb is more powerful, having 4 scientific instruments to help it make its observations. These are the near-infrared camera, NIRCam, the near-infrared spectrograph, NIRSpec, the mid-infrared camera, MIRI, and the fine guidance sensor near-infrared imager and slitless spectrograph, FGS NIRIS. These instruments will help the Webb telescope to perform what is known as imaging spectroscopy. This means that it can take an image, but it will be taking a spectrum and every pixel in the image as well. When it comes to imaging spectroscopy, information will be available on the spectrum of wavelengths that are present in each tiny piece of the image. This will give scientists a clue as to what elements or chemicals might have created that spectrum. Just as the Hubble telescope was launched in 1990, the Webb telescope has brought a new era of observational astronomy. Webb is bound to see further back than Hubble's infrared vision, expanding our perspective to the far reaches of the universe. The Webb telescope is bound to change everything, and we are yet to see the first images. What do you think of the images produced by the Webb telescope? Feel free to let us know in the comment section below. Also, before you go, make sure you leave a like and subscribe to our channel for more amazing updates on space. Thanks for watching, and I'll see you in the next one.